We are good to go. Let's just break in real fast. Okay, so today I changed up the schedule just a little bit. So if you go into Blackboard, you'll kind of see the rest of the semester what we have going on. We're going to go over sections 9A, B, and C kind of in order. So A today, B Wednesday, C next Monday. And then I believe we have the text test either next Wednesday or the Monday after. I can't remember off the top of my head. But what matters today is we're going to go over 9A. 9A is not a long section. I'm going to actually kind of review some stuff before we really get into the section that if we kind of went through the whole book, we would have seen. But, this class is more about kind of picking and choosing out of the book as we go. So today's 9A. It should not be a long section. The goal is to get this homework done and make sure you understand the concepts. I think it's only about maybe 5 pages in the book. So let's get started. Let me switch over to the document camera. Okay, before we get started, let's talk a little bit about graphs and then domain and range. It'll help us how your book defines it later on. So let's just talk about graphing coordinates first. So, in a coordinate plane, you have 2 axes. Now, this axis is usually called the x-axis. But I want to introduce another kind of lingo term in there, and it's going to be the independent. The independent axis. The independent variable is going to sit here on this horizontal x-axis. So the book uses this term a lot in this section. So I want to kind of show you where it comes from, and we'll talk a little bit more about it once we get into kind of the word problem aspect of it. So the x-axis is right here. Independent. What else? Oh, it's also called the domain, right? Our domain is this x-axis. So x-axis, independent variable, and domain are all right here. Now the y-axis, though, which is this vertical axis, we're going to call the dependent variable. And it's also called the range. Okay, so these 3 things kind of all mean the same thing. If you hear y-axis, it's the dependent variable. It's also the range. Okay, x-axis, independent variable, and the domain. Now, these axes were actually developed, kind of notationally developed. They've been around for a long time, but they were notationally developed by a French philosopher named René Descartes. And you've probably heard about René. You definitely heard one of his most famous sayings, which is now in a flippin' Billie Eilish song. The other day I heard it on the radio. But I think, therefore I am. That is René Descartes. I got a nice kick out of hearing that on the radio. So anyway, René was a French philosopher. He developed a lot of neat stuff. And one of the many things that he gave us was this Cartesian coordinate plane. Now, again, it was around before René. It's just that he really gave us the universal notation of it, kind of the language of it. Okay, what was happening at the time was there was a lot of information being spread amongst mathematicians and philosophers, and there wasn't a universal way to notate it. So him and another guy actually kind of developed this universal way of notating. Now, Cartesian is actually Descartes. Excuse me, Descartes in Latin is Cartesius, and that's where the Cartesian aspect comes from. So we've got this XY axis. Thank you, René Descartes. He's French, and he has a really, you know what? I'm going to talk for like 2 minutes about René because he intrigues me. René was really world-renowned philosopher of his time. Like he was famous while he was alive, which was kind of rare at the time for these great philosophers. But at the end of his life, this is what I found one of the many things that's interesting about him, actually. But at the end of his life, he was really kind of being, he was a celebrity, and all of the wealthy established like kings and queens wanted to be tutored by him. And there was this famous, I believe, Spanish queen that wanted to be tutored by Renee. So she paid to be tutored by Renee, no big deal. And Renee comes to Spain. I think it's Spain. It'll be Spain in the story. Renee comes to Spain, and the the queen wanted the tutoring to happen early in the morning each day. And Renee actually didn't like this. He was a very sickly child. And the story of him actually developing this coordinate plane, the kind of old wives' tale story of it, is that it happened because he was a sickly child. And he wanted to know, like, how could he tell someone in another room if there was a fly on the ceiling, on like a gridded ceiling? How could he tell someone exactly where that fly was if they were in another room? That's kind of debated if it's true or not. But but he was a sickly child. That has been published, and it is a known fact. Well, so he gets to Spain, and the queen wants him to wake up early every morning, and he isn't about that lifestyle. So he tries to explain that to her, but he's like, "Hey, look," she's like, "Hey, look, I'm paying you. This is what you're supposed to do." And it turns out he winds up dying, and the kind of joke is he died because he was lazy, right? The queen, of course, in Spain just thought he was lazy, but actually he died because he was kind of a sickly person. But because he had to wake up early in the morning, he died. And that's Rene Descartes. But anyway, let's get back to this XY axis. Now, what's neat about the XY axis is that you have these coordinates, and they can be graphed. Okay, so a coordinate is going to have an x variable first and a y variable second. So really, it's going to go domain first, and then range second. Now, if we're looking just at a regular kind of numerical coordinate plane, we'll do some basic coordinates here. Look, these are separate coordinates. They do not connect. It's just random coordinates on a plane, okay? So if we had like 1, 2, the coordinate 1, 2, well, this first coordinate's going to be our domain variable. That's our x-axis. So we're going to go over 1, and then the second coordinate is our y variable, up 2. Over 1, up 2, and boom. That would be the coordinate 1, 2. Let's use some different colors here. So if we wanted the coordinate, let's say -1, -2. Okay, we'll change it up. -1, -2. Now, I haven't really talked about the positive and negatives, but this middle, where these x and y axes overlap, that's called the origin, and it's always 0, 0. So the numbers to the right are going to be positive, and to the left are going to be negative. And this is with the y axis. The numbers above are going to be positive and below are going to be negative. Okay, so if I wanted to graph -1, -2, I would go to the left one, right? Because that's our domain value. So left 1 and then down 2. Boom. There is our -1, -2 coordinate. Let's take some colors out. So let's say I had a 0 in there. What if I had like -3, 0? Well, for -3, 0, so -3 on the x-axis still, right? So I'm going to go 1, 2, 3. But then I don't go up or down, right? It's just sitting on the x-axis. So it's going to be right there. And then let's say let's put one of this other quadrant here. 3, -1. So 3, -1, that's a brown. I'm not sure if you can see it, but you go over 3, 1, 2, 3, and then down 1. Okay. Those are examples of using the coordinate plane to graph ordered pairs. That was the word I'm going for. These are also called ordered pairs. Okay, ordered pairs. Awesome. Okay, I think that's the kind of backup and for the review information we need before we get started. And because your book starts with ordered pairs. This is on page 516. Your book really starts with ordered pairs. And it says, there's a lot of words there, but in the end it says, I'm going to read some bold stuff. The purpose of a mathematical model is similar to that of an architectural model or a roadmap. It represents something real and helps us understand it. So this section is really about mathematical modeling, and we're going to start by creating these ordered pairs to kind of show the math modeling, to show the model, but with a visual math context. Okay. So the very first thing your book goes over then is the independent and dependent variables. So the quantity, okay, suppose we want to model the variation in temperature over the course of a day. Based on the data in table 9.1, which is at the bottom of 516. It's okay if you don't have a book out, we'll get there. The first step is to recognize that two quantities are involved in this model, time and temperature. Our goal is to express the relationship between time and temperature in the form of a function. Now, if we define function, you know what? Let's. Oh no. Okay, your book kind of goes over it. Second, but so we'll get there. But let's start with talking about these ordered pairs and putting them into a dependent and an independent, and what that means when it comes to modeling. Ooh, excuse me. So let's look at these ordered pairs. We're only going to do a few. Let's say we do 6 to noon. So we've got time and we've got temperature. Okay, we've got time. We have temperature. And these are just ordered pairs. So it starts with 6 a.m. and it says the temperature is 50 degrees Fahrenheit. Okay. And then at 7 a.m., it's 52 degrees Fahrenheit. And then at 8 a.m., we'll just stop here. 8 a.m., it's 55 degrees Fahrenheit. Okay. These are examples of ordered pair. Now they're written differently, right? They're written in this grid form and not in this parentheses form. If you wanted to write it in grid form, you're more than welcome to. It would be 6 a.m., 50 degrees Fahrenheit, 7 a.m., 52 degrees Fahrenheit, and 8 a.m. and 55 degrees Fahrenheit, right? Now, remember the X value here, this first value is called the independent variable, right? This is the independent variable. So this first value is always going to be the independent, and the second value is always going to be the dependent. And so what's happening is the temperature here depends on the time. That's what they're trying to say. There's this relationship between time and temperature, right? And the temperature during the day depends on the time for this day. Now, there's not like a storm coming in or anything like that. It's just the time. So the temperature depends on time. So therefore, time is an independent variable, right? It just keeps going. There's nothing that really, it's not depending on anything, except I guess the rotation of the earth and things like that. But the temperature, though, for that day just depends on the time in that day. That's where your terminology for dependent and independent variable comes from. If we let's look at another example. Let's see here. Hold on. Let me kind of make up a goofy example. Let's say we surveyed people's salaries. Okay, so so our X is going to be your salary, and the Y is going to be the number of times you eat out in a month. So you go to a restaurant in a month, right? And we just start surveying people, right? So these are just, so X is going to be salary. And then number of restaurant visits. Okay, we'll put it like that just to make it shorter. Number of restaurant visits. So the first person we go to, actually, we're going to kind of line these up in order. And let's say the first salary is somebody makes $24,000 and they go out to eat 4 times a month. And then the next person makes $30,000 and they go out to eat 6 times a month. And the next person makes $45,000. They go out to eat 8 times a month. And then 60,000. And they go out to eat 15 times a month. Okay. And I mean, this is definitely hypothetical. There's no truth to this by any means. But what we're noticing is that the number of times you eat out per month depends on your salary, right? As salary increases, the number of restaurant visits increases, right? So therefore, we'd say that the salary is the independent variable, and then the restaurant is the dependent, right? So the number of restaurant visits depends on your salary. Okay. I mean, you could look at this at like, number of times you use your umbrella and the amount of rainfall each month, right? The number of times you use your umbrella depends on the amount of rainfall. We've talked about this in the correlation and causation section in the previous section. This is actually kind of similar, but it's just a little different how we're going to model based off of it. Okay. Modeling based off of it. The next section your book goes over is the function. Actually, it talks about functions, and it talks about writing functions. Hold on, let me see here. Let's look at the green box on page 518. It says, a function describes how a dependent variable changes with respect to one or more independent variables. When there are only two variables, we may denote the relationship as an ordered pair with the independent variable first, right? We've talked about this. Independent variable goes first, dependent second. We say that the dependent variable is a function of the independent variable. X is the independent variable and y is the dependent variable. We write the function as y equals f of x. So this is the math language aspect of this. So f of x, or y, is now going to be written as f of x. Okay? And what this means is that, now look, this is not f times x. This is a notation thing. Okay? This means y is a function of x. Okay, y is a function of x. Y is a function of, so salary is it's kind of goofy, but yeah, salary is a function of the number of, I'm sorry, hold on. I got this backwards. Maybe x is a function of y. The dependent. Yeah, I got this backwards. Sorry, guys. X is a function of y. It didn't make sense when I started using the language, but yeah. So what we're saying, if we bring it back to here, what this means is that, the number of restaurants you visit is a function of your salary, right? The number of restaurants depends on your salary. So it's the same kind of aspect. So X is a function of y. And what we do is we do write this in this form. So let's look at this example. Actually, I can write this this form in this example. Now let's think of coordinate pairs first, or ordered pairs, however you want to think of it. This first ordered pair would be 24K, so 24,004. I'm just going to write 24K to make it easier. 30K and 6, 45K and 8, and 60K and 15. Okay. Now, if I was going to use this notation, I could write all of these in this function notation. So the way that would work, now I'm going to write these in order. I don't mean to make it seem like I'm going on. Think of it more like if I was going to the right. If I was going to write this in function notation, so 24K and 4, well, the y actually goes first. 4 is a function of 24K, right? So 4, if you eat out 4 times a week, that shows that it's actually related to, it depends on the fact that your salary is 24K. So 6 equals f of 30K. And we say it like that. So 6 equals f of 30K. Now, we're not multiplying, it's just a function thing. So 8 equals f of 45K. And 15 equals f of 60K. Okay, so these right here, let's kind of use a different. There's 3 ways to write the same exact thing. We can write it in kind of this table form with our salaries and our restaurant visits. We can write it as ordered pair, coordinate pairs, and we can also write it as function notations. These are all 3 the same thing, just notationally written differently. Okay, it's almost like saying the same thing in 3 different languages sort of. It's maybe if they were all Latin based or something like that, and you say it in 3 different languages that are Latin based, but they're definitely they all mean the same exact thing. Okay. Let's. Yeah, your book then goes over domain and range. I know I already kind of did that, but if you look at page 520, it says the domain of the function is the set of values that both make sense and are of interest for the independent variable. Okay, so let's just stop here for a minute. So for us, the domain values are going to be salary, right? So they're saying salary is the set of values that both make sense and are of interest for the number of restaurant visits, the independent variable. I'm sorry, the salaries, not restaurant visits. The range, though, of functions consists of the values of the dependent variable that correspond to the values in the domain. So these are going to be, of course, the range values, and they consist of the values the dependent variable that corresponds to the values in the domain. And look, what happens is that the y values correspond to their x value. Okay, the y values correspond to their x value, kind of vice versa. The x values correspond to their y value. Now, I can also ask this a little differently. I'm going to try to, I'll leave it up here so you can at least see the bottom part. I might ask, or the book might ask, for the domain and the range. Now, remember, the domain values are the x values, they're the first values. The range are the y values. And if it asks for the domain and the range separate, it's asking for the set of domain values. So if we go back up here, our domain values are 24K, 30K, 45K, and 60K. If you're going to write a set of numbers, you use this squiggly bracket. Now, typically with numbers, we write them in ascending order, right? So the smallest is 24K. The next biggest is 30K. The next is 45K. And then lastly, we've got 60K, okay? That would be the domain of this function, okay? The range of the function would just be the y values. And same thing, we would write them ascendingly. Now, this doesn't mean that these two correspond with each other, okay? We don't have to write it like that. We could write 15 next if we wanted. It's not a big deal. I know there's probably some mathematician out there that cringed when I said that, but since it's a set of numbers, the order doesn't matter. Okay, so 4, 6, 8, and 15. We got the squiggle bracket. So if your book asks for domain and range separately, which it probably will, you would just write them out as a set. Okay, they would be a set of each. Yes. Okay, hold on. Yeah, okay, very straightforward. I want you to read that last page, and it really talks about building the model off of kind of basic examples, which is great. And then I want you to hit the homework. So the homework is going to be on page 523. This is 9A, numbers 920, 524. 9A 1 through, it's not going to be that much, 1 through 41. 1 through 41, odd. Okay, 1 through 41, odd. Okay, that is all today. It's a short section. Wednesday, we're going to go over 9B, which really talks about modeling more in depth. That's why I want you to read those last two sections in this section in 9A. It kind of bounces off from there for 9B. It really goes into the linear modeling. So we'll go into what if there was incremental change, as X increases, there was incremental change to Y, up or down, right? So, if I had money in my bank account, $100 in my bank account, and then every month a $5 fee came out for Netflix, which is not $5 anymore, but let's say it was $5 still. Well, if you don't put any money into the bank account, then it just starts at 100 and then it goes down $5 each month, right? And then what we're going to do in the next section is model that mathematically, make the equation for it, okay? That's what this section builds to. So have that kind of in the back of your mind as you're working the homework. Okay, you guys that are in here, any questions before I call it a day? If you want to stick around after I stop the video, you're more than welcome.